Okay, now I'm gonna run now a market model. Okay, that I just I have alpha returns and the market returns, and then I'm gonna run a what is called a market model, a market regression model, where I'm gonna use it as a dependent variable the continuously returns of alpha, and as an independent variable the continuously compounded returns of the market. Then with the command regress, I'm just going to run this model, and I can see that basically what I have to look at is this output. Here I have the independent variable that the market returns, and this coefficient 1.019 is actually the beta 1 of the regression model. In terms of the market model, this corresponds to the beta, to the uh, market risk of alpha. Even though I'm looking here the market returns, this beta corresponds to the market risk of alpha. It's a little bit confusing sometimes, but this 1.01 is the alpha beta of the model, and this is the standard error of beta 1. This is the t value of beta 1, the p value of beta 1, and the confidence interval. What does it mean is that the beta coefficient is 1.01 and is statistically significantly different than 0. What does it mean is that there is an actual really positive relationship between the market returns and alpha returns, and this cons is the beta 0 of the market model, is the point where the line that represents this relationship crosses the y-axis, and it's a little bit further more than 0. Okay, and here the p-value is significant. When the p-value, when a coefficient is significant, you gotta look at the p-value. If the p-value is less than 0.05, that means that the coefficient is statistically significantly different than 0. Okay, in this case it means that the beta 0 is significantly greater than 0. Then in terms of a market model, this represents the alpha of the market model. Then the alpha represents the excess returns that the alpha is showing systematically over time. That means that in this case, in this time period, alpha has presented um, returns in excess of 2.5% over the market, and here it indicates that the beta 1, the market risk of alpha, has been statistically greater than 0. Okay, if I want to know if in a market model, what I'm interested is in learning if the market beta of the stock is significantly different than 1. In this case, the traditional regression output does not show me that. This p-value corresponds to the hypothesis, to the null hypothesis, whether or not the beta coefficient is equal or different than 0. Then if I want to know how how statistically significantly different than 1, what I have to do is to run the test command. Okay, in this case I use this underscore b. It means that I'm using the value of the coefficient of the beta coefficient of the beta 1. Then when I run this one, I can see that the p-value is much greater than 0.05. That means that the market beta of alpha is not significantly different than 1. Then we can say that alpha has the same risk as the market, or another interpretation is that when the market increases in 1%, it is expected that the returns of alpha will increase also in 1% in the same direction. can be positive or can be negative. Okay, I'm gonna stop here.